Third time is the charm. Okay, so we're going to write a fourth degree Maclaurin polynomial for e to the x. We're going to use the polynomial to evaluate square root of e, which is actually what? E to the 1/2. So we're really just plugging 1/2 into our polynomial. That's what we're actually doing. Okay, so the Maclaurin polynomial for e to the x is what?
X to the n plus x squared
over 2
factorial plus x cubed over 3 factorial plus dot dot dot.
Well, we're doing the fourth degree, so we're going to go to the fourth. So x to the fourth over 4 factorial. And then we can go ahead and plug in 1/2. So feel free to get your calculators out. I'm not going to do this for you. Wolf, how are you going to get the answer if you don't even type anything? You'll just never know. Nobody tell Wolf. Wolf will never know the answer. I'm going to put... You're fine? I'm just putting my answer right underneath the glare so that you can't see it. I know.
I'm not even sure if mine is right now.
Oh, man. This is like, isn't that good?
You really cannot see it at all.
I know.
You can see the 7.5.
Yeah, so you can kind of, if you guys got it, you can kind of check that you got it. But, oh, man. Right? Ugh. I love it so much.
I mean,
do you have a 7.5 at the end?
yeah.
Okay, nobody tell Wolf. Nobody tell Wolf.
You can put them all in your head, but you're not going to add 340.
I'm going to store this as A for approximation, because in the next answer we're going to have to do our interval, so I'm just going to store this as A. Store as A. Where's the glare? There's...
Oh no, now you're showing the middle part.
That's okay. All right. So now we're going to say, okay, the difference between f of 1/2...
Now that we've all got it, can we make sure that we've got it?
No.
Okay.
We're pretty sure we have it. We're pretty sure we have it. We're making sure that when Elena watches this tomorrow, she has to calculate it also.
Good luck, Elena.
Good luck, Elena.
She could just pause it when it was not in the glare.
Whoa, don't tell her that. Maybe she wouldn't have known it. All right, so less than or equal to. And then how do we construct the next part?
What should we write here?
You can. The reason I'm writing it like this is because when they present it in problems, they write this more often. They don't ever use the word error from what I've noticed. So I think you probably could write the word error, but I'm going to do this so you're used to it. Yeah.
You take the fifth number, if it was to the fifth.
Mm-hmm. But we don't just automatically take the next one. What do we have to do about it? No, look at your notes. This is the weird part. This is the Lagrange part.
Are you multiplying by the...
Yeah, I don't know that. I don't have it explained.
The max of the fifth derivative. What about it? On the interval. And what's the interval?
It's negative 0.5 to 0.5.
Not negative 0.5 to 0.5. 0 to 0.5. 0 to 0.5.
Wait, can it be negative? Is it not the absolute value there?
It's, you typically use the number that it's centered around and then the number that you're plugging in. So 0 is what it's centered around. The number that we're plugging in is 1/2. Now it says the maximum error for negative 0.5 to 5, right? That's the absolute value part that you're talking about. However, plugging in a negative exponent is going to make a fraction. That's not going to be the biggest number. Does that make sense? Okay. Times, and then I'm going to say x to the 5th over 5 factorial. Okay, now what I did, and actually, we don't know what these derivatives are, so let's go ahead and do them off to the side. Why did I say that in my funny voice?
You put add 1/2 to that.
Anyone know? Because it's e to the x. So it's e to the x. I was making a math joke and nobody was paying attention, so nobody
Good
noticed.
thing you made him do it. You got the wrong answer.
I forgot there was an x. I just put 1 in and went straight to x squared.
Okay. So here's the graph of e to the x. Here's the interval. We've got 0, which is 1. We've got 1/2, which is bigger than 1, right? So what we're going to do is we're going to say, okay, let's use the upper side of that. So we're going to use e to the 1/2 as the number for our coefficient. Does that make sense? Because it was bigger. It was the biggest value on the interval. Okay. So I'm going to go ahead and write that the error is e to the 1/2 times 1/2 to the 5th over 5 factorial. Mm-hmm. 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 Oh, dang it. 1/2 to the 5th. I have a tendency to always plug in 1 for x. I don't know why, but I usually forget to plug in the value.
The only way to get the factorial thing is doing that and then go all the way.
Well, there might be a faster way.
Math perm.
I got that.
I'm a math perm.
So the error is less than or equal to, I'm going to go ahead and take this decimal place and move it 4 places to the left. So it's 0.12343. There's the error. And I'm going to go ahead and store this as E for error. And then to make my interval, I'm going to say that square root E is between the approximation minus the error and the approximation plus the error. Should we do 3 decimals or 4? What do you guys think?
4.
4, because 3 would be silly.
I would do 5. Which one's gonna be?
I would just love to see somebody do 3 decimal places and just not even notice that the answer is ridiculous. Somewhere between 1.648 and 1.648. The part about this problem that annoys me the absolute most is that we are approximating e to the 1/2 and we plug it in to get the answer. Oh, that feels weird.
What does it say after
Wait,
equal
you
half?
always-
I literally
you
can't
always
read that.
plug
My eyes are not.
You always, so sometimes they'll give you,
1/2 to the 5th.
sometimes they'll give you a graph to use. So let's say they gave us this graph and we didn't actually know what that exact value was. That would make a little bit more sense because then I would be like 2, 4, 6, 8. I'd be like, okay, maybe let's do like
1.75.
Or even like a little bit bigger than that, just to err on the side of caution. Maybe I'll do like 1.8 or something, and then it truly would have been an estimation where it'd be like, yeah, I really didn't know what e to the 1/2 was. But since we're using our calculators, it just is funny to me that we're using e to the 1/2
Can we,
to calculate the error that we got off of e to the 1/2, because supposedly we don't know it.
Just to err on the side of caution, we always use the number of billion.
Yeah, please don't do that. You'll be like, my answer is somewhere between negative 1 billion and positive 1 billion. Somewhere in there.
If you did that on an FRQ, how would you feel about
They would reach through the paper and punch you in the face. All right, here's the next one.
That's pretty reasonable reaction.
I think so. The function f has derivatives of all orders. F of 2 is 6, f prime of 2 is 4, f double prime is negative 7, f triple prime is 8. Write the third degree Taylor polynomial and use it to approximate f of 2.3. So, f of x is approximately 6 plus, what do I write next? Not x minus 2. Okay, and then f of 2.3. Now, if you want, some people like to type in, I'm just going to show you this. You'll be like, Mr. Rice, that's pointless on this problem. I don't care. 2.3, I'm going to store it as x. And then if I want to type this problem in using the x's, I can. Instead, on this problem, I don't know that it's going to speed things up at all, but on some other problems, yeah, on this problem, you could just do 0.3.
But when it's like a lot more complicated.
But some problems, yeah, it's actually really helpful. You guys better be typing because I'm about to move the... You guys are all just waiting.
So you
Miss
don't
Rice
have
is
to
my
do
calculator.
parentheses with like the 7 x minus 2, like that parentheses. But you don't have to do like from 8 to 6. You don't have that.
Yeah, order of operations. Exactly right. Yep. Let me move it up to where the glare is. There we go.
Ooh! It's a really pretty fraction.
Oh, look at that beautiful number we got. Very nice. If you type it all in with the x in there,
And then hit enter on phone.
hit enter, it will give you a funky answer, store x, and then just go up and grab it, and it'll do it. Yeah.
Mr. Rice, take one guess what the fraction's going to be.
Take one guess.
One guess.
Just one.
The fraction isn't really nice.
Add a 0 and divide by 1,000.
That's what it is. That's what I said. It's not nice.
Yeah, I know. I was being.
Hold on. I'm going to give you my one guess in a second, okay?
So because you would say you would be.
As I would also say, you were being pedantic.
Indeed.
Indubitably.
Is it 2,763 divided by 500?
No. It's you literally take the thing and multiply it.
By 10 and then put it over 1,000. Or not
Not by 10, you multiply it by 1,000.
Wait, no, stop.
You multiply the top and bottom by 1,000 and that's it.
Yeah. It doesn't
It's just the answer over 1,000. That's all it is.
I know I did that, and then I reduced it.
Don't reduce.
But it's an even number. Oh, it's not an even number.
It's a prime number.
Okay, sassy.
Okay.
All right. So the answer is 6.921, right?
Yeah.
Okay. Now it says
6,920.
the fourth derivative satisfies this. So are we going to need to graph something?
Toby, it's not a prime
It's not
number.
prime.
Are we going to need a picture of a graph? Are we going to need a table of some sort? No, because they're telling us what the derivative is. They're giving us that specific value. So I'm still going to go ahead and write it out because these are my notes and I want to make sure that this makes sense. This was the third degree. I'm going to go ahead right up here. I'm just going to call this p sub 3 of x. So f of 2.3 minus p sub 3 of 2.3 is less than or equal to the max of the fourth derivative on the interval. And what's the interval? 2 to 2.3. I know that because they gave it to me, but I also know that because the center was 2 and I'm plugging in 2.3. Okay? Times...
So is the center always the first constraint?
Or it could be the second, depending on the numbers you're plugging in, whichever one's bigger. X minus 2 to the fourth over 4 factorial.
I cannot see it all today. Is that
Max of the fourth derivative onto...
I thought 4, but I couldn't.
Yeah.
It looked like you had just done 2 hash marks. I was like, why in 7?
So when we plug the numbers in, what are we going to have? Nine for the derivative times
8 times, or 0.3 to the fourth.
0.3 to the fourth over 4 factorial, whatever that happens to be.
What's going on with you?
I stored 2 in X, and so I kept getting 6. I'm not
Can we just go to the first derivative though?
Can we go back to derivatives?
Right?
Can we just do the first unit again, just for fun?
Yeah.
Oh yeah. Still.
I do not like limits.
Yeah, but
You'd probably like it now.
Like,
I still don't like them.
I love
I
it.
still don't
I
like
Okay. They want us to make an interval. I'm going to go ahead and store this as E.
Grace, you want to know what a number is at a number, but you can't go to that number. You just have to look at what it's doing.
Yeah, I did not put like what did you do with them?
So the
If you
interval...
can't plug in 0 to 1 over x. You
Toby,
can look at what the graph does.
Is this one that's in continuity?
Yeah.
I'm asking, is this unit?
Yes.
Why are we being such sassy people today?
Yes, can I ask a question?
Okay, so there's our interval, because it said to write the interval, right? So I just went ahead and I stored my error and I stored my approximation and I did approximation minus error, approximation plus error, so I know the actual answer is in between those two numbers. Could the evaluation be 6.992?
No.
No. Why not?
It's not on the interval.
It is not on the interval.
See, I can't know because I can't see.
Thank goodness you are capable of doing math on your own paper.
Well, I'm in the middle.
All right.
You ask me a question and I go to like, oh, can it?
And then you're like, I don't know, I can't read that. Marvelous. All right. I do cackle. How are we feeling about it?
We're feeling a certain way.
Confused, but still good.
So a lot of these problems are calculator active. When it gets to the test, they will be inactive because it's always number 6. So they will give you the nicer numbers.
I honestly feel like the calculator active questions are way scarier.
Yeah, I think the answers get like, woo, real bad.
Yeah, you can't just, like, I mean, you know, most of the time you can hide stuff if it's kind of interactive, but like, the calculator does very strange things in calculating stuff.
You alright?
There we
Your flex?
Okay.
Okay.
Did you say beard flex?
Oh yeah. Flex does.
These are not stapled yet, sorry.
Mr. Rice, you can put the hair around your face. Mr. Rice, why don't you put them all together and staple them all in one big go?
That's not a thing.
Also, why
That's
did
not how stapling works.
You work out
though.
though.
Staple all the papers together. That way we don't work from our one big book of math.
We're not communists.
Are we though?
Stick it in.
That isn't stapling.
This is our classroom, comrade. Our math.
All right.
Blake just goes, nah.
Let's start number 1.
Uh-oh. I think he's having some.
If it's at the end of its staples, then it doesn't staple well.
Toby, just use this stapler.
Amazing job, Toby.
All right. Same thing. Let's just make sure that we're good, okay? So, did you guys notice there's a different calculator today? Yesterday's was pink. Today's is white. That's right. I like to mix it up.
Do you have more staples?
Be a little, yeah, they're on my desk in the little blue container. All right. There are values, right? Values of h and its first 4 derivatives are on the table below. The function of these 4 derivatives are increasing, and they will use the Lagrange error band to show that the third degree polynomial for h about x equals 2 approximates h of 1.9 with an error less than 3 times 10 to the negative 4. Do we have to find the approximation?
Did you have a good staple?
Oh.
No, we do not have to find the approximation. We just have to find the error, which is kind of nice. Okay, so I'm going to say that h of 1.9 minus the third degree polynomial, so the error is less than or equal to the max of which derivative?
The fourth.
The fourth. On an interval. 1 to 3.
1 to 3. Right.
So what center are we using?
2.
2. What are we plugging in?
1, 2.
So the center is 2.
Uh-huh.
We're plugging in 1.9. So it should be 1.9 to 2. Okay. Times what?
The
How is that term going to be made using the numbers? How do we make the term? Not x to the 5 over 5 factorial. It's fourth derivative. This is the third degree, so we're using fourth derivative. It's not centered at 0, it's centered at 2.
X minus 2 to the 4th over 4 factorial.
Over 4 factorial.
4.
Yep, because it was a third degree. And so we're using the fourth derivative, fourth exponent, fourth factorial. Okay. All right, so the error.
Don't we have to use put a number in front of it, the coefficient for the...
Yep, so if I look on the table, the best option I have is the 584 over 9. I don't have anything else I can use.
Yikes.
That's all I got.
Why couldn't we have used it at 1?
We could if you want to get the answer wrong.
I'll just approximate from 1.9 at 1.
Just go ahead and use 1 billion.
Wait, sorry, so there have to be the coefficient in front of the 19.
Think about how we make the terms, right?
Yeah, but
We put the derivative in front, then we do x minus whatever the center is to that exponent divided by the factorial. So I am forming this just like I normally form a term. Yep. It's exactly the way you form a term. You're just saying that instead of using the derivative at the center, you're just going to use the maximum of the derivative on the interval because we're being conservative. We're using a bigger number if we can. So maybe it's the derivative at 2, maybe it's the derivative at 1.9. We're just going to do our best to find the biggest number so that we have a better error. All right, so now that's a calculator question. Oh, and we want this. This is less than 10 times, nope, 3 times 10 to the negative 4. Okay, so we've got 584 over 9 times 1.9 minus 2 to the 4th divided by 24. Get the glare in the right spot.
Oh boy, that's
Get right there.
Moving the zero.
Oh.
Zero.
Dang it.
Yeah.
What part do I cover? What part?
Yeah, I would cover the front part.
There we go. That's the best way to do it.
You got it.
Okay, did you guys get the answer? I'm sorry. I'm having way too much fun today. Okay, so the error
0.00027.
Stop exposing it.
It's been exposed.
I'm gonna move my decimal 4 places to the left, so I've got 0.00027, which is less than this one. If I were to move the decimal, would be 0.0003.
It's a cool repeating number. It's 0.002703703703703703703703703.
Yeah.
Wonder why it does that.
Maybe you should do some research.
I will. That will be my PhD thesis.
Marvelous. All right, next problem. Whew, okay. We'll have the 3rd degree polynomial. Okay, so they're saying of the following, which is the smallest value for k, and then here they're giving us the error, okay? So I'm just going to go ahead and write the error. Is less than or equal to the max of what?
Max of
F4, okay. The 4th derivative of x on the interval 0 to 1. We're plugging in 0. Now, notice the intervals in terms of x, and then, Marley, the interval you had noticed was in terms of n, and so that was telling you that this is going to give you your derivative for the 1st derivative through the 4th derivative. So that this is where the derivatives are coming from. Okay. Times, how do we make our each term? X to the 4th. Okay. So it's our 4th derivative, so what are we going to plug in here?
4.
Plug in 4 and we get 4/5 times, and then what are we plugging in for x? 1, because that's what we're approximating. That's not 14, that's a 1 to the 4th. It's just very hard to write.
I'm just going to do 1 over 4.
I was like, why is he so excited? Oh yeah, it's a factorial.
120.
Oh, actually, don't even do anything, because this is what the answers look like.
Oh, there you go. Oh, there you go, B.
B. I went to plug it in my calculator. It's not even a calculator problem.
I want to plug it in my head.
What a terrible...
4 over 120, which is 1/30.
Okay. Do you still want to keep doing some together, or do you feel like you can move on by yourself now?
I feel like we could try and do on our own.
So that's the smallest
It's not the smallest value you can get. It's how far off you could be. That's like a comfortable approximation.
With the alternating series one, we had that like a sentence we'd have to write to do that.
It's kind of like either you use alternating or everything else is going to be Lagrange.
Alternating is showing up far too much for my loading.
Alternating when it's
Alternating is
series is alternating.
The series is going back and forth. And the interesting thing about alternating is that you can see it in the series when it's got the -1 to the n in the front. But sometimes a series doesn't have a -1 in the front. You plug something in and it ends up alternating. And then you can use the alternating series error bound.
And it has to be.
It has to be decreasing.
Which most of them.
Yeah, they typically are.
Which means it's converging.
Yep. So you could either say it's converging by the alternating series test. Therefore, now I'm going to go ahead and use alternating series error bound. Or you can say it's an alternating series that's decreasing, which is another way of saying converging. And so I'm going to use the alternating series error bound. All right. We good? All the answers are in the back. There are lots of problems, so just get as far as you can, and then we'll figure out how we want to narrow it down.
And
Okay.
then we have another notes video tonight.
Yeah, after everything we've done so far, when you watch the video tonight, you're going to be like, ooh, that's easy.
But that's our last video.
That's our last video, Thursday review, Friday test.
Can we choose?
Please don't.
Interesting. No,
Are we
every
doing a
time.
study session Thursday?
Wait.
Study session Thursday. What time do we want the study session?
9.
No.
Five. Just do five. Like
Five.
we always do.
5.
That's okay. We've got rehearsal going. Thursday review session.
What time is the rehearsal?
5.
5 to anywhere. Well, it might, sometimes
2
it
minutes
ends.
down the road.
Sometimes it ends at 5:30 or later, depending on this song.
Wait, so the rehearsal can go from 5 to 5:30 or
No,
like
no,
5 to
no,
11?
3:30 and it could go to 5.
Oh.
Yes.
Oh, okay. So,
Well, there's that.
yeah, so
You
we
said
can
5.
start at 5, I'll hang around.
5.
So if you guys get out at 6:30, still come on over and I'll hang out.
Toby's bad with words. I was like, I'm blaming you.
I'll stay as long as you guys are there. You'll get there at 8:40 because you have rehearsal and then other things.
Because I said, well, we've got rehearsal only, and he said, yes.
Um,
When's rehearsal start? And he said, what are we talking about? I said, well, we've got a review session at 5. Oh, well, rehearsal starts at 5, but sometimes it starts at 5:30.
I could potentially.
Not when I
Are you
said
busy
that.
tomorrow too?
I did not say start.
Yeah, you did.
Yes.
I said rehearsal. Rehearsal.
Well, we have a half
No.
day to go.
Yeah, that's the other thing is if you guys want to, if a few of you want to stay after school tomorrow after the half day, I could hang out with you and do
I
math.
didn't say start. I implied that by accident because I was.
Yeah.
Mm.